Start with the concept of symmetry in fluids. In physics, symmetry means that something appears the same even if you move it or turn it around. Liquids like water are known for their high symmetry because their particles move randomly and freely. Imagine rotating a glass of water. No matter how you turn it, the liquid inside looks identical. This randomness and constant shifting give fluids the highest possible level of symmetry. It's as if the particles are always mixing and never settling, making liquids unique compared to other states of matter. Understanding this symmetry helps us appreciate why liquids behave the way they do, setting the stage for exploring how their particles interact. Study liquids. Scientists often use the hard sphere model. Picture atoms as tiny billiard balls. They can't be squished or overlap, and they always need their own space. The most important rule in this model is repulsion. Particles push each other away if they get too close. Interestingly, in this basic model, temperature doesn't affect how the particles behave. They either touch and push back or they don't touch at all. This simple idea helps us understand how liquids maintain their structure and why they don't compress easily. By visualizing atoms as hard spheres, we gain insight into the fundamental interactions that govern liquid behavior. Even though liquids seem messy, there's a hidden organization called short-range order. Each particle is usually surrounded by a shell of about 6 to 12 neighbors, forming a tiny cluster. Just outside this first group, there's a small empty space before the next set of particles begins. However, this pattern only lasts for a few layers. If you look further away, the arrangement becomes completely random again. This subtle structure helps explain why liquids have both fluidity and a touch of organization. It's fascinating to see how, beneath the surface chaos, there's a brief moment of order among the particles. Matter isn't just liquid or solid, sometimes it's somewhere in between. Liquid crystals are a fascinating example of this middle ground. In a normal liquid, particles move randomly and face any direction, showing low order. In a solid crystal, particles are perfectly organized in a repeating grid, showing high order. Liquid crystals, however, have partial order. Their particles flow like a liquid but all point in one direction. This unique state allows liquid crystals to be used in technologies like screens and displays. Understanding these levels of order helps us see how matter can behave in surprising ways, bridging the gap between fluidity and structure.